CCQ.
Hello, sorry about that. Welcome back to CQ, the AWS Certification quiz show. Today we are actually concentrating on a topic rather than a specific exam. So it will be associate level questions and we're looking specifically at storage.
Excellent.
Luke, maybe you can tell us a little bit why we're
Again?
looking at storage today. Again,
Shall I
yeah.
introduce myself again
Yeah,
as
that would
well?
be fantastic.
So Luke Anderson, I'm part of the storage team across APAC, as my title has just come up about here. So regardless of the title, I still think I have one of the best roles in AWS. So
It's a big call, Luke.
I know, but I get the opportunity to work with customers day in, day out, as well as the teams that actually build the features and products that we see released to market. And as we know, over 90-95% of our features and services are built based on customer feedback. So I see myself as integral to some of the new features and services coming out across the APAC region. So
Well, I'll
one of the
tell you
best
how
roles.
integral you are when we get into the questions, eh?
Ah, and there's questions.
Yeah.
Okay, now show me up. Okay.
Fantastic. So please feel free to vote along online once our poll starts by clicking the number of the answer that you think it is. Luke, are you ready to jump into some questions with me today?
Let's see what we've got.
Indeed. Alrighty, first question of the day. Archiving data. Sounds like we're starting easy on you, Luke.
Well, it could be, but archiving data isn't as straightforward as you think.
Let's see, shall we? Okay, you have some historical data that you wish to archive. It is accessed on average only once per year. This is the only copy of the data, so you wish to keep it in multiple physical locations. What would be the most cost-effective way to store it?
Okay, so before we dive into any of the answers there, the four possible answers, let's break down the question. So it's historical data that we want to archive. So we know it's not hot or readily accessible data like some movies or online streaming like OTT providers.
Okay.
The other one, big one there is it's accessed only once per year. So that's important just to note. We're not going to do anything with that yet, but that's the access patterns of the data. So we need to understand that one.
Mm-hmm.
The other two areas that sort of stand out to me, it is your only copy of data. So it's authoritative. So
Is that a common thing?
very common theme. So if you think about any of the banking organizations or insurance companies or even health records, they often only have one copy of a customer's data. So whether it's your health record or whether it's an insurance claim,
Okay.
and some regulatory or legislation means you have to keep that copy of that for about 7 years at least. So we call it sometimes your gold copy. You can't ever lose that.
Got it.
And it's to be stored across multiple physical locations. What I read into that is we've got to make sure that it's going to be durable. So if you ever need to get it back, you can pretty much trust it's going to be there. And the last one, it is cost effective.
So a few things we got to get right.
Yeah,
here.
so it's not as straightforward as you may have thought. So looking through the four answers, now each one of them, from reading through them, could possibly work. It would
okay.
It would be a viable solution to store data. But let's go through each one of them.
see which is
S3
the
standard
best.
infrequent access.
So I like infrequent. We wanted infrequent access.
Yep, so this is all of our object storage. So a lot of the archive data gets stored in object storage,
Yep.
which is how we support object storage is through our Amazon S3 service. Now, the S3 service is broken down to 6 different storage tiers. So I'm not really answering the question here, but it helps sort of dive into some of the reasons why. So starting at our hottest storage, so data that you need to access all the time, you're going to be writing data into it all the time, it's called S3 standard. If you only need to access it, say, once or twice per month, you can store it in standard infrequent access.
Okay.
Now
that's the infrequency.
Yeah, so
on
that
this
is a
one.
lower cost to store the data, but it's a higher cost to retrieve the data.
Got it.
Okay.
Yep.
The next one down is one zone or S3 one zone infrequent access. I'll cover that one in a second. The next one down is Glacier, which was our archive service we launched a few years ago. And then our new service that we launched, our new storage tier we launched back in March, April timeframe earlier this year, was Glacier Deep Archive, which is our coldest storage. Now, as we go through the tiers, it starts at more expensive way to store your data through to very low cost way of storing the data. But on the flip side, the costs to retrieve the data sort of are converse to that, which is why we have to be mindful of where we store it. Now, I did say I'd come back to one zone, but I also missed out one storage tier. I said we had 6, and I've only discussed 5.
Yep.
A new one we launched a few months ago this year is intelligent tiering. So we have customers who go, Well, I just don't know. I don't know whether I need to access it every day, or I don't know if it's going to be accessed once a month.
Bit harder to predict.
Yeah, exactly. Yeah. So we do have management tools and analytic tools that you can access through our console to work out the access patterns of the data, but not all of our customers have the capacity or capability to be able to do that and perform that. So we launched intelligent tiering, which sort of takes a rules-based machine learning approach to the access patterns of your data, and then categorizes that data based on the access patterns without you having to worry about it. So that's our sixth storage tier.
Got it.
Now, 5 of the 6, not including OneZone, are written, each object is stored at a minimum 3 availability zones. So if you remember, a region is, so we have our Sydney region, and each region is comprised of multiple availability zones, and each availability zone could be multiple physical locations. So OneZone, so all the other 5 storage tiers are stored across a minimum 3 availability zones, providing 11 nines of durability.
Wow.
Now, OneZone in frequent access, now OneZone being in the name, we only store that object at 1 availability zone. It could still be across multiple physical locations, but only in 1 availability zone.
Got you. So cross out number 2.
So yeah, so let's work through the answer. So standard and frequent access, it would work, but let's look at the question. It's only accessed once per year, so let's rule that one out. OneZone in frequent access, I know it says multiple physical locations, but let's sort of say, well, let's call it multiple AZ. So let's kind of rule out infrequent access. Plus also the reason it's our only authoritative copy of the data. So more is going to be better for this one. So let's rule out OneZone. Deep archive, again, could be an option. And then the 4th one is Glacier, could also be an option as well.
And we're looking for the most cost effective.
And the last one is the most cost effective. So we go right down to our 6th storage tier, which is Deep Archive, number 3.
So locking in number 3. Let's
3.
have a quick check on the poll. 63% agreeing with you. So your diagram didn't quite work. Maybe we'll pop it in the chat for everyone to have a quick look at.
Okay.
Karthik, if you could pop that in the chat, that'd be fantastic. Answer to question 1 was indeed number 3. Off to a fantastic start.
And that's it, yes? That's it, the only question.
No. Let's move on to question number 2. All right, shared storage. Here we go. You need to provision shared file storage among several hundred Amazon EC2 Windows instances. Permissions must be managed via an existing Active Directory server. How would you provide this storage? File storage. Here we go.
Okay, so it is file storage, but the key thing is in the question, is in the actual subject of the question, Windows shared storage. Because file storage could either be NFS or SMB. Now for NFS, we have Amazon EFS, Elastic File System, for that support. Now we're focusing on Windows shared storage. So we have hundreds of EC2 Windows instances, which now have to access a single shared file system where permissions are managed via an Active Directory. Now, what it doesn't say there is whether it's an AWS managed directory or whether it's an on-premise directory, but let's just assume all our access permissions are through AD. How would we provide this storage? Now, first one is WorkDoc Sync Client. That could be a solution, but WorkDocs and WorkDoc Sync Client is more for file sharing for some of our user home directories and so on. I wouldn't really link this to a sort of enterprise workload with one EC2.
Some more object.
Map Amazon S3 to network drive to each instance. I mean, there are third-party solutions like Cloudberry out there that do provide a network drive for S3, but again, that's not dying into Active Directory. Use Amazon FSx Windows File Server, which is our new service that we launched across the APAC region in the Sydney, Sing and ICN regions early this year, which is our managed service for native Windows file system support.
So pretty much exactly what we're looking for.
Yeah, that is pretty much what we're looking for, and the poll is suggesting.
But let's just check.
But then share an EBS volume from a Windows server using SMB. Now, previous to FSx being launched on the market, this was one potential option. You could create an EBS volume and mount it using SMB, but again, that's a lot of overhead, and we need to talk about integrating to Active Directory. So for me, the best one here is number 3.
100%. Oh, it's gone down actually. It's now back to 8. I don't know what you did there, but you confused a few people.
While talking.
Number 3 is. But we got there in the end. All right, let's try for 100%. Everyone, remember to vote online as we go. Question number 3, EFS. That you were just talking about. Look at that, it's perfect. An Amazon EFS file system contains critical company data. You wish to perform a daily backup of the files. What is the most efficient way to back up the EFS file system?
Okay. So Amazon Elastic File System is similar to FSX for Windows, which is our managed file system for Microsoft workloads, Microsoft file system. Amazon EFS is our managed service, but for more the NFS file systems, which are commonly used with Linux or Unix platforms.
Got it.
So some of the common workloads we're seeing here is providing shared file system support for containers, any sort of DevOps, continuous improvement, continuous development, logs, and code. So it's used quite heavily for mission critical applications. So this question is quite relevant to some things I see. Now, previously, we had customers saying, how do we back up an EFS file system? It's containing critical information. How you used to previously do this, I say previously, I'll explain why in a minute, was create a replica really of that EFS file system onto another EFS file system.
Okay.
And we had some code and CloudFormation scripts that were available on GitHub to do that. What we've launched since January this year is AWS Backup, which is a native AWS service to back
Fully
up
managed.
a number of AWS services.
Okay.
So EFS, Storage Gateway, EBS, RDS, and DynamoDB are currently supported at the moment. And EFS is the key one here. Now let's go through each one of them. So as I said that, I think we'll start seeing, just looking at the poll, okay, so 50-50
at the minute.
So let's use rsync to copy the files to an EBS provisioned IOPS volumes. Now, that would work. Yes, it is.
Yeah.
So rsync works. I've used it for probably over 20 years. It's around. It's great for copying files for Unix and Linux file systems. It's like robocopy in the Windows world.
Yep.
So, but to do that, you'd have to create an EBS volume. You'd have to manage that volume. You'd have to have somewhere or a server to run that command from to copy the data. So it doesn't seem the most efficient way to back up an EFS file system. Use AWS S3 Sync to replicate to S3. Again, that's overhead. It may work, but there could be you'd have to manage that one.
Okay.
Create a backup plan in AWS Backup. Well, that seems the simplest because you can manage that all through the AWS console. You can log on. It's directly integrated to EFS. You can manage the policies and retentions all through the console. So that works. And the fourth, activate EFS versioning at a file system level.
People online are liking at the minute, Luke.
I know, but this is maybe I'm calling myself out here, but I haven't actually heard of EFS versioning. I've heard of S3 versioning for bucket level versioning, but I haven't actually heard of EFS versioning.
I definitely think that one's a red herring.
Okay, so that's
Don't
where.
doubt yourself.
Yeah. Okay, let's see what the answer is.
All right, so locking in number 3.
Yep.
3 it was.
Good.
I think I just heard a sigh of relief there. Luke, was it?
Yeah, it was. I'm testing my knowledge here.
All right, let's go. On to backups. Perfect. Your company performs daily backups of on-prem computer systems to tape backup systems. Data has continued to grow, requiring more tape storage. However, the data center has run out of space for additional equipment. How can you utilize the cloud for backups with minimal impact on current backup processes?
Okay.
Nice. It's a mouthful, actually.
It is actually, and this is a common
Very
conversation
common, yeah.
we're having with our customers as well. So, a typical backup environment is you have your backup application running on a media server that writes the data to a media server that then either writes it to disk or tape silos.
Yep.
Very common environment, backs up the application, backs up your operating systems, backs up databases as well. And they're using a whole host of third-party applications to do that, and very commonly known. So what we have here is data is continuing to grow, and you can see that. We see that through any sort of analyst reports. Data is getting richer, there's more of it, the volume and velocity of data is increasing, so it's becoming a burden for existing data centers.
Yep.
Either existing tape silos are running out of capacity, even with the evolutions in tape from LTO7 to LTO8 being able to store more data on there, they're still running out of capacity. And it's coming up to hardware refresh life cycles. So with every sort of hardware instance, you've got to refresh it every few years, every 3 to 5 years. So it's becoming a burden. But on the flip side of that, we hear our customers go, well, let's move to the cloud, but we don't want to have an upheaval of our current IT processes and technology. What can we do? That's the simplest way of keeping the existing backup software, the existing backup jobs, and rather than point it to tape, point it to an endpoint on the cloud. Okay, so that's the current scenario. So let's look through some of the answers here. So we have use the AWS Storage Gateway. Now, the AWS Storage Gateway is our hybrid or a stretch into on-prem storage architectures. So the Storage Gateway has 3 flavors. File Gateway, which is NFS and SMB. Volume Gateway, which is mounts a volume, presents it locally. And the third one is our Tape Gateway, which provides a virtual tape library instance, not a virtual tape backup instance. So
Noted.
Let's change the word backup to library.
Yeah.
So what that means,
update,
let's take that virtual tape library. That presents an iSCSI interface to your backup application. So where the backup application is writing through iSCSI to a tape library, we can present an iSCSI interface on virtual tape library that you can just point your backup application to, and then that writes the data to AWS. Through the same, it creates virtual. So
that's your connection between that on-prem and cloud services.
And we do the same thing as we mimic how a tape library would present tapes. So we present virtual tapes, which are actually backed by S3. And then when you eject the tape or virtually eject the tape, it goes to archive, and that goes to Glacier and now Deep Archive as well. So same sort of use case.
So I'm liking that answer, but let's double check on the others.
Well, true, but then you can back up data directly to S3. That also works.
Yep.
A number of the third-party applications that you can find on our website have now direct native S3 API support. So if you're using one of these supported third parties, you can literally on the console, on their console, drop down where the endpoint is, and one of the endpoints will be Amazon S3. Some are also now supporting Glacier, and a couple of them are also supporting Deep Archive. So option 2 and 3 would also work.
But we're looking for minimal impact on the current backup process. Is that your differentiator?
And then we rule out number 4 because that's create a backup plan on AWS backup. So that service is running on AWS, not on premise. So we rule out 4. How do we rule out 2 and 3? We say with the minimal impact on current backup process. It's a little bit more, you have to set up more, you have to change your understanding of where data's being stored. Okay. So let's rule those out and lock in number 1.
Number 1, 71% online, agreeing with you.
I think they're right. They're right.
All right, let's reveal number 4. Number 1 it is. Well done, Luke. Halfway through.
Halfway
100%
through, wow.
so far.
Good. We end now, yeah? So
You got a few minutes. All right, let's move to question 5. Let's see how many we get through today. You have an Amazon S3 bucket with millions of existing objects, and hundreds of objects are being added each day. Management has requested a weekly audit that lists all objects and their metadata. What is the most efficient way to obtain this listing?
Okay. Becoming an ever-increasing challenge we see with Amazon S3. Yeah. So it says with millions of existing objects, we have customers, I'm speaking to them weekly, who have billions of existing objects. Now, a lot of these objects need to be referenced and indexed for other applications' use. So think of the retail environment. So if you want to have different promotions for different items that you have that you want to be able to sell that you have in stock, you want to be able to reference an S3 bucket very quickly to be able to put them on the website dynamically. Yep. Now, there are ways to efficiently optimize your S3 bucket, which we're not going to go into here. But there are other methods as well to be able to create a listing. So with S3, there's an inventory command, which is basically like a list. It's a command that you can run, or an option within the console that shows all the list of what objects you have within which bucket with certain permissions and other metadata associated.
Wow, you make it sound so simple.
It is very simple.
There you go.
It literally is an inventory button on the console. So there's that way. So let's go through some of the options. Use the AWS command line interface. So you could do this. Okay. You could log in, or you could do like an ls command or a list command across all your buckets. Sure. To find out what's in there, concatenate that to a single file, and then send it out to your team for the weekly audit. Probably is a bit of management overhead on there. Isn't you're going to have to store it somewhere, time, right? And it takes a longer time. Yeah. Use Amazon Elastic MapReduce to list multiple object prefixes in parallel. That just seems like a lot of overkill
yeah, it does.
to just prepare a listing. Use Amazon S3 Inventory. I'm leaning towards that one at the moment, but I have seen 4 used before. So use a Lambda function to update a DynamoDB table whenever objects are added and deleted.
Bit more manual.
Now, how do we split 3 and 4 out? It's a weekly audit.
Yeah.
So If it was real-time access and you had other applications wanting to get real dynamic listing of what's in S3, DynamoDB table may be an approach you could investigate. But if it's a weekly audit, it's not time sensitive, I'd go for use the S3 inventory.
Locking in number 3.
Yep.
Paul is agreeing with you yet again, Luke. Feeling happy with yourself?
Oh, very.
No?
Very, yeah.
3 it is.
Yep.
All right, let's move on to question number 6, remote data. Ready?
Yeah, it's a good one.
Okay, good. You wish to collect and process sensor data at a remote mining site that has limited internet connectivity. Simple anomaly, I did it right, okay. Detection will be run locally.
Glad you're reading this.
The data will then periodically be sent to AWS for storage, aggregation, and detailed analysis. How can this be accomplished using AWS services?
Okay, key one here. And
That was a hard one to read.
It is,
I'm just saying.
I'm not even going to try and read it. I was going to pick out keywords.
Okay, cool.
So, sensor data. So, sensor data at remote mining site. So, we assume the remote mining site, as it says, has limited internet connectivity. So, we assume it's going to be connected only occasionally. So, it's got to be a standalone component.
At the site.
Standalone at the site. It's a remote mining site. So, we can't just go and take a server or a laptop and leave it there because it could get damaged. So, we need something ruggedized, that's standalone, that can store data. And then I'm looking through the last bit.
You don't want to read any of that out?
No, I'm
good.
happy with how you read it, actually. I'll probably trip over. So it seems like if they're doing sensor data, they may want to run some computation on there as well. It says some detailed analysis.
Yep.
So we almost need a standalone, ruggedized appliance with compute and storage capabilities.
Yeah, we need that compute, right?
Yep. There is only one that has that.
Yes, there is.
Which is AWS Snowball Edge. And beginning this year, we now have 2 flavors of Snowball Edge, which is compute optimized and storage optimized. And basically it says what one is geared more for storing more data, one it has more processing capability.
Perfect.
So that's what I'm leaning towards. But let's just walk through the other one. So use Amazon S3 Transfer Acceleration. Now you use this when you have 2 buckets in different AWS regions and you want to accelerate the transfer of data between the 2. We use the Amazon network backbone to be able to accelerate the transfer. Well, that's not going to work at a remote mining site with internet challenges. Use AWS IoT locally, then transmit the data using site-to-site VPN.
A lot of people like this one on the poll. Luke.
Yeah, but I'm not sure what AWS IoT locally is.
Me neither.
So on the Snowball Edge, you can install things like Greengrass.
Okay.
And with our new EC2 instance, you could start having computational IoT type applications running on there, but I don't know what AWS IoT locally is. So, and if you're using site-to-site VPN, that kind of infers you've got a little bit better internet quality.
Yeah.
So I'd rule that one out. Install T2 microinstances at the work site with VPC peering back to AWS. Nice idea, but we don't necessarily ship T2 microinstances externally. Now, this question may change when AWS Outposts is launched,
there you go.
but that is still currently planned for future, but it was early announced at reInvent, so that still isn't released to market. So, and anyway, we don't have T2 microinstances.
So we might have to bring you back in once that's announced for a new set of questions.
Exactly.
Okay.
So for this one, it's number 1.
All right, number 1. Everyone's still geared towards number 3 online, so hopefully 1 it is. All right, let's move on to question 7, and I think this will be the last one we can just about fit in today, Luke.
Okay.
You ready?
Okay.
Management has asked you to make weekly backups of EC2 instances in case configs needed to be rolled back. What is the most efficient way to do this?
Okay, so weekly backups. So we're assuming these are online hot backups. We can't shut things down for this. This is an online hot backup, and we're looking at the easiest, most efficient way to do this.
Yeah.
Create a cron job that on each instance to back up to S3. Well, yeah, you could, but it's an overhead, management, and so on. Plus, you'd have to rely on the success of the cron job. So you'd have to log in afterwards to make sure it's successfully run.
Yeah.
It's probably the most optimal
So
way of using
more.
data. Doesn't necessarily include incremental changes, so probably not that one. Use CloudWatch events to create an AMI, an Amazon machine image, each week. Now, my understanding is to do that, you'd have to shut down the instance to prevent any sort of file locking and any sort of dirty data in there. So I'd rule that one out because you have to shut down the instance. Trigger a weekly Lambda function to replicate the EBS volume to a cold store. That just seems like you're doing a snapshot without using the snapshot capability. And as we move on to the fourth one, create a snapshot lifecycle policy using the Amazon DLM, Data Lifecycle Manager. So that's something that you can automate. It's an AWS managed snapshot. It controls and manages the incrementals as well. And for the most efficient way for an online backup, I'd pick number 4.
Locking in number 4, a bit of a mix online, but number 4 it is. Luke, thank you so much for joining us today. That whizzed over a bit after we had our bit of a upset start at the beginning. Thank you so much.
I'm glad it's working.
We'll bring you back on after these new updates come out, I think.
Sound
good?
Thanks
so much for joining us, guys.
Thanks,
we'll be back next week for a look at the SysOps Associate Level exam. Thank you.
Bye.